Now that we have imagined the data we wish to have, let's look at what we actually have by breaking it down into actual metadata and definition, defining the system, mapping inputs, outputs, and levers, expected KPIs and engineered figures, type of analysis and hypothesis formation. Going back to our previous mapping, let's try to map the actual variable in those four buckets, starting with operational. Number one is trip UID. The definition is the unique ID for a specific trip. Second is route schedule UID. It is the ID for the planned route schedule. Third is the route type. This is the transport mode, and this can be either FTL, which stands for full truckload, or carting. Our second one is spatial. In this, we have source center and source name. As the name imply, it is the IDs given to the center and name. Similarly, the destination center and destination name. Actual distance to destination. This is the kilometer between the source and destination. OSRM distance. Think of it like a Google Map distance, which give you the shortest path distance. Segment OSRM distance. This is planned OSRM distance per segment. The third one is temporal. In this, we have trip creation time, the timestamp when the trip was created, OSRM time, the OSRM ETA under usual traffic, cutoff timestamp, the timestamp of cutoff applied, OD start time, this is the actual start time, OD end time, this is the actual trip end time, segment OSRM time, this is the planned OSRM time per segment, segment actual time, this is observed time per segment, start scan to end scan. This is door to door elapsed time, and actual time, this is actual time taken. And the last category is the external. These are generally core business related variable and is cutoff where the trip falls under the cutoff window. There is a cutoff factor, numeric factor tied to that cutoff logic. There's a factor, this is not yet known. When we see at the example, we will come to know. Segment factor, this is again related to segment level on the factor logic that is there in the data. And using the combination of these variable, we should be able to find out the efficiency as well as delay, as we discussed before. Now that we know the term definition as well as the broader category in which each term belongs, let's try to map them according to the input, output, and levers or process. Um, this type of approach is called systems approach, and this mapping is also called as systems mapping, in which the first part is the input. In input, you would see any variable which is going to set the background of the story. Story over here is trip completion. In terms of data, it would mean one line item or one row. So all those variable which is going to set the initial background is going to come into inputs. For example, source center, source name, destination center and name, trip creation time, route type, actual distance to destination, OSRM distance, OSRM time. OSRM in this context or in this data refers to the third party app which is going to give us a rough estimate of the time taken to cover that distance. For example, it could be Google Map. Moving on to the next step, which is the process. And in process, we generally see levers. Levers are nothing but the factor which directly affects the output. And any change in these factors is going to exponentially change the output. Levers are of two types. First one is the process or business related lever. And the second one is the environmental lever. Process levers are the ones which we have our direct control. Business has the direct control over it, whereas the environmental lever are something that is governed by like the overall ecosystem. We do not have much control over it. In this process control lever, we see is cutoff factor, cutoff timestamp, and factor are four major variable belonging to this bucket. As of now, we can understand that these four sets some kind of threshold, and breaching which is going to impact our business. When we look at the actual data, the real sense will emerge. Next is the execution or in transit variable. We have the OD start time, OD end time, segment OSRM distance, segment OSRM time, segment actual time, and segment factor. All this is going to set the context of what happened in when the truck actually started to move. And all this variable ultimately affects start scan to end scan time and the actual time. Scan time is something which is like process driven, we can say, but the actual time is, of course, it is governed by our efficiencies or our processes. But again, there could be delay because of any XYZ environmental reason. So actual time is influenced by both environmental lever and process lever, and start to end scan time is like majorly governed with our business or our efficiencies. We have now arrived at a stage which is often considered as the backbone of any good data science problem, which is the features that we are going to engineer and the KPIs that we are going to derive. Let's try to have a look at what the KPIs or what are the various features which is going to make sense in the network or transportation problem. Starting first with network reliability index. This is the percentage of trip actual time which falls within a factor of 1.2 times the OSRM time. OSRM time again for the reference is the Google Map time. Now, using this index, we should be able to find out the stability as well as the route consistency. Second one is the throughput per center. This is calculated by taking the count of the trip completed within the active hours of that hub, and it gives us the hub efficiency. Third one is the cutoff compliance rate. This is calculated by taking the percentage trip within the cutoff window, and this is going to tell us the execution discipline. Next is operational slack ratio. This is calculated by taking a difference of actual start versus the planned start and compare it with the planned duration. Now, this helps us quantify the ideal lag before the dispatch. Next is the segment level stability. This is calculated by taking a standard deviation of segment actual time and compare it with the mean of segment actual time. And this helps us detect within trip variability. This completes the KPI. Now, let's take a list of features that we can engineer, starting with spatial temporal friction. This is calculated by taking a difference of actual time minus the Google Map time and compare it with the distance. Now, this gives us the travel inefficiency per kilometers. Next is the batch density. This is calculated by taking the number of trip sharing cutoff as compared to the hour, and this is going to give us the load balancing signal. Next is the cutoff punctuality. This is calculated by taking the sigmoid of trip start with the cutoff time, and this helps us to quantify the lateness severity. Next is the route predictability. This is calculated by taking the difference of s- ratio of standard deviation per mean of any route and taking a difference by 1. This helps us to give the reliability of route duration. Next is the segment bottleneck ratio. This is calculated by taking the maximum of segment actual and compare it with the total of segment actual. And now this helps us to identify or pinpoint the worst performing leg. Time of the day efficiency. This is calculated by taking mean of delay ratio by hour. Next and last one is the route congestion proxy. This is the median delay for the same order in past 24 hours. Now that we know the term definition, the broader category in which each term belongs, the systems mapping, expected KPIs and features that would make sense, let's try to look at various analysis that we can do and how we can frame our hypothesis to get answer from this data. What I've done here is try to curate a list of all dimensions that would make sense in a network or transportation related problem. And using this dimension, this will give you a mental map or a roadmap to think of the core question, which you can get the answer from either calculating a KPI or doing a descriptive analytics or plotting a chart or things in this direction, or you can answer these core questions by the hypothesis as well. Um, the objective is that testing this hypothesis will indirectly give answer to your core question. You can take screenshot of this core question and dimension table that I've curated, and you can make your own sets of hypotheses to test. That would be a good exercise. Let's try to think how we can come up with this structure, given that we have enough knowledge or the business background to come up with dimension. Let's take a look at network efficiency analysis. So the very basic thing that we can do is we can calculate the total time which is productive versus the idle. Now this can be calculated with a direct KPI, or we can frame a hypothesis which we can do a testing, which goes something like the carting routes which has more than 3 stops spends more than 40% of the trip idle at hub. Similarly, you can make your own question and hypothesis along the lines of process discipline, forecast reliability, spatial bottleneck, temporal load, batch density, route structural analysis, operational slack, customer promise. And once we have all this groundwork ready, we should be in a good position to solve any question regarding to the given data.